एंगुलर डिस्प्लेसमेंट की चीज है, सुनिया कदे नाम?
नहीं सर।
ओके, suppose particle is moving in this circle, सर्कल है, ठीक है सर?
आफ्टरनून सर।
हेलो बेटा, की हाल चाल?
बढ़िया सर।
Okay, particle is moving in this circle, it moves from A to B, okay? ਤਾਂ ਇਹਨੂੰ ਆਪਾਂ ਕੀ ਕਹਿੰਦੇ ਆ? This, what about this? ਕੀ pronounce ਕਰਦੇ ਆ ਇਹਨੂੰ?
सर कॉर्ड।
हाँ, it is arc, right? This is arc AB. And what about the distance from center to point A? That is radius. Now, here is angle that is subtended by arc at the center. We may write it d theta. Length of arc, let it be dx. Now, by definition, what is length of what is the definition of angle? D theta is equal to AB upon R. So here it is d theta. What is AB? dx. What is radius? R. So अपने को रिलेशन आ गया dx is equal to r d theta. So dx is the linear distance that body moves from A to B and d theta is angular distance. ठीक है सर? Then अपने को टर्म आती है angular speed. Angular speed denote कर दिया omega and definition says omega is d theta by dt. See, if we differentiate equation 1 with respect to time, so क्या आ जाएगा? d by dt of it is dx, it is equal to d by dt of this is r d theta. d by dt of x, ddt of x, sir, in the velocity. R, sir, R is constant, so it is taken out of integration. Now here it is v is equal to r omega. Okay, so angular displacement, how we get the angular displacement and linear displacement? Angular displacement multiply radius is linear displacement. Similarly, angular speed multiplied by radius is linear speed. So relation आ गए. Now we have centripetal force. It is centripetal force. What is centripetal force? The force which makes the particle move in a circle. Okay, means if centripetal force is there, particle will be moving in circle. Okay sir, ठीक है. Force is a vector quantity. Centripetal force की key direction है. It is a vector quantity. See, it always act along the radius. Suppose particle is here. This is the center. Particle is moving in this circle. So this centripetal force act along the radius towards the center. पिटल का मतलब होता है लविंग, सेंटर लविंग फोर्स. सो कितने आएगी फोर्स? कितने एक्ट कर दी है? इट इज अ फोर्स एक्टिंग ऑन अ पार्टिकल, ओके, मूविंग इन अ सर्कल. मूविंग इन अ सर्कल, ओके. कितना एक्ट कर दी है? इट एक्ट along the radius towards the center. Okay, what is expression for centripetal force? Example पहला गल डिस्कस कर लिए. Centripetal force की कोई example? Do you know in daily life which is moving in circle? कुछ है इधर ਜਿਹੜਾ ਸਰਕਲ ਚ ਮੂਵ ਕਰ ਰਿਹਾ
Sir, time.
ਹਾਂ okay see earth around sun earth around sun this is moving in a circular path circular orbit ਜਿਹੜਾ ਇਹਦਾ orbit ਹੈ earth ਦਾ circle ਹੈ ਹੁਣ sun is holding the earth towards it and earth is moving suppose earth stop moving around the sun what will happen earth will fall on the sun okay that is why earth is revolving around the sun so that it may not fall on the earth similarly electrons ne electrons around nucleus electrons around nucleus what will happen if electrons start revolving sun te gir jayega hun earth around sun ਦੇ ਵਿੱਚ centripetal force ਕੀ ਹੈ it is gravitational force which is acting as a centripetal force ਹੁਣ ਇੱਕ ਹੋਰ important ਗੱਲ gravitational force is a source of centripetal force okay what about electrons around nucleus electric force positive and negative charge they attract each other electric force is the source of centripetal force source है होएगी कि नहीं देखो अगर आप फर्स्ट एग्जांपल दी गल करिए centripetal force whenever particle moves in a circle centripetal force is mv square by r या we can write mr omega square either of the two दोनों से कुछ भी लिख लो सेम गल है फर्स्ट केस ਦੇ ਵਿੱਚ mv square by r is given by gravitational force gmm by r square second case it is given by electric force जितनी भी force होएगी whatever the force is there between the particle towards the center that will be the centripetal force ਉਹਨੂੰ ਲਿਖਾਂਗੇ ਕਿ ਉਹਨੂੰ ਲਿਖਾਂਗੇ mv square by r ਹੋਏਗੀ ਕਿ ਨਹੀਂ that is the source whether it is a gravitational force or it is electric force that act as the source of centripetal force say centripetal force clear hoyi
Yes, sir.
ਕੀ ਹੁੰਦੀ ਹੈ centripetal force beta that makes particle moving in a circle it act along the radius towards the center expression is mv square by r now what is formula what is unit of centripetal force Newton what is dimension formula of centripetal force mlt minus 2 it is simplest it is a force unit and dimension formula is same as that of the normal force
Okay, sir.
okay now we have car in circular track motion of a car in a circular track car hai it is moving in circular track what we need see there are two types of path one is level other is banked on the road is circle okay its outer edge is raised with respect to inner edge so that is banked circular track first we will talk about car on a level circular track ठीक है sir how to describe this path देखो अपने कोल ये एक कार है it is moving in level circular track r is the radius of the circular track m is the mass of car this is a car it is moving in a on a rather level circular track. इस तरह this is a circular track. ओके, लेवल है, हॉरिजॉन्टल है. It is moving in a level circular track. This is a circular track. Okay. What we thought of? अपा की कंसिडर करेंगे R की है रेडियस ऑफ सर्कुलर ट्रैक. ठीक है सर. M मास ऑफ कार, व्हीकल भी लिखा जा सकता है. फर्स्ट वी विल कंसीडर द सिचुएशन विदाउट फ्रिक्शन. If car is taking a circular turn, it needs a centripetal force. That centripetal force will act along the radius towards the center. इधर लगेगी वो centripetal force. Now suppose there is no friction. There is no friction acting between the road and the vehicle. Then due to inertia, car will skid. So without friction, it is not possible to take a circular turn. सहज गल समझ आई अमृत बेटा?
Yes.
So without friction,
Yes, sir.
हाँ ठीक है, without friction possible नहीं है. We will talk about optimum speed. Optimum speed is what should be the maximum speed, what should be the speed is the safe to take the circular turn. So ਆਪਾਂ ਕੀ ਕਰਾਂਗੇ? देखो, in this case ਜਿਹੜੀ friction force है, that is the source of centripetal force. So ये centripetal force कौन provide कर रहा है? Here centripetal force is given by कौन दे रहा है? Frictional force. Okay, याद करो, what is centripetal force? Sir, you told us that centripetal force is mv square by r, and here is the source of friction which is providing the centripetal force. Acha, what is friction force? So law of friction, it is mu n. Since it is a horizontal surface, it means normal reaction is equal to weight. So अपने को किया गया, अपने को आ जाएगा mv square by r is equal to mu mg. M and m cancels out. So we are left with v is equal to under root mu rg. Now this is the safe limit. If a vehicle takes circular turn within the range of this speed by using the value of coefficient of friction, radius and g, we will get the safe limit. But limitation की है, this is frictional dependent. Okay, limitation is this is not fixed, this is not constant. Friction force depends upon coefficient of friction, which varies from tire to tire. The nature of the surfaces in contact. So mu is different for different vehicle. So it means this velocity safe limit is different for different vehicle. Then what to do? Here we consider there is no friction between. Here we consider the speed is optimum and the road is level. Now we will talk about maximum speed. Second point है, second point की है banking of circular track. That was level circular track. This is banking of circular track. What is banking of circular track? Banking of circular track ਦਾ ਮਤਲਬ ਕੀ ਹੁੰਦਾ ਹੈ ਪਤਾ ਹੈ ਅਮ੍ਰਿਤ?
सर मैंने पता
ਕੀ ਦੱਸੋ?
सर की रोड थोड़ी भी चेंज कर दी जाती है
Yes, road outer edge of the road is taken up with reference to inner edge. See this diagram. Okay, area. Now road is inner edge of the road is banked with respect to outer edge. Okay, ठीक है sir. So here this is angle of banking, area angle theta इथे. So outer edge, banking means outer edge is raised with respect to inner edge. Angle ਨੂੰ ਕੀ ਕਹਿੰਦੇ ਆ? At angle theta, that is known as banking angle. Known as banking angle. Okay, ठीक है. Now what will happen? See, when the vehicle will take turn on this circular track, it will try to skid outward, so the friction force will act here along the track downward area. This is force of friction. Okay sir, ठीक है. This is force of friction. If we draw a horizontal line here, you can see okay, अगर A एंगल थीटा है तो इथे A भी एंगल थीटा हो गया. यस सर. फोर्स ऑफ फ्रिक्शन दो कंपोनेंट हो गए. जिस साइड नाल एंगल बन रहा है सर वो हो गया कॉस कंपोनेंट, एंड परपेंडिकुलर टू दैट इज साइन कंपोनेंट. ठीक है सर. F cos component towards the center, F sin component it is vertically downward. Here normal reaction, it can also be resolved into two: n cos theta vertically up, n sin theta towards the center. Now what is centripetal force here? N is resolved as एक किया गया n cos theta upward, दूसरा किया गया n sin theta towards center of track, ਜਿਹੜਾ ट्रैक ਦਾ center ਹੈ ਉੱਧਰ. Similarly F friction force ਇਹਨੂੰ ਵੀ resolve ਕਰ ਲਿਆ. How it is resolved? F sin theta, F sin theta it is downward, and second F cos theta it is towards center. Therefore centripetal force, sir, centripetal force you told us it is mv square by r, and the centripetal force is force acting towards the center. Now if we can see here, there are two forces that acting towards the center. One is n sin theta, other is f cos theta. So mv square by r किधर equal आ गया? It is f cos theta plus n sin theta. Okay sir, got it. At the same time along the vertical n cos theta is equal to mg. Also mg किधर equal आ गया? Sir mg is n cos theta. ठीक है सर. शायद दोनों इक्वेशंस क्लियर हो गया बेटा।
हाँ जी सर।
हम डिवाइड कर दियो 1/2, इट विल बी m कैंसल, v स्क्वायर बाय r g, it will be f cos theta plus n sin theta along vertical, एक मिनट, प्लस mg, एक सेकेंड बेटा, along vertical n cos theta is mg plus f sin theta, so here it will be vertically किया जाएगा mg is equal to n cos theta minus f sin theta, so divide कर दो, it will be n cos theta minus f sin theta. Okay sir, ठीक है. From this we'll get v is equal to, देखो, अंडर रूट आर जी, ठीक है सर, अंडर रूट आर जी ਆਪਾਂ ਕੀ ਪੁੱਟ ਕੀਤਾ, f is equal to mu n ਪੁੱਟ ਕਰਤਾ, ਸੀ f is equal to mu n, ਇੱਥੇ f is equal to mu n ਇੱਥੇ, सो n कॉमन आके कैंसिल हो जाएगा, बिल्कुल ठीक. ऊपर कौन बचा, ऊपर बच गया साइन थीटा प्लस म्यू कॉस थीटा, नीचे की बच गया सर, नीचे बच गया कॉस थीटा माइनस म्यू साइन थीटा. देखो मैं गलत नहीं किया किते, चेक करो बेटा. हाँ जी डियर, कोई गड़बड़ता नहीं. इट इज f इज इक्वल टू म्यू n, सो मैं साइन थीटा पहला लिखता प्लस म्यू कॉस थीटा. नाउ दिस इज द मैक्सिमम स्पीड with which vehicle can take circular turn on banked circular track. ठीक है सर, but at the same time if we neglect friction, if neglecting friction, मान लो फ्रिक्शन नहीं है, हम म्यू ने 0 पुट कर दो, सो v क्या आ गया सर, v आ गया अंडर रूट आर जी. देखो म्यू 0, ए भी टर्म गई, ए भी टर्म गई, साइन बाय कॉस, इट इज टेंजेंट थीटा. ओहो, it means sir, if the road is banked we don't need friction to take circular turn. Answer is yes, we don't need friction. But here on the level circular track, if friction is not there, the circular turn is not possible. So this is what the benefit of banked circular track. We don't need any friction, that saves wear and tear of the tires. Tire the wear and tear bach jandi kyunki there no friction is coming into action. Yes, but if the speed is kept up to this only, if the speed increases then this is the limit, here the friction will come into account. But if the speed increases from this also, then the vehicle will skid. So in this case we don't need any friction force. Now this is maximum speed, ਇਹਨੂੰ ਆਪਾਂ ਕੀ ਕਵਾਂਗੇ, maximum speed, and this is optimum speed. Okay, derivation clear हुई सहज, अमृत?
Yes, sir.
Now last is cyclist on circular track. There is a cyclist which is moving on a circular track. Simple, this is a circular track. Now cyclist is taking turn, so the cyclist need to bend a bit. This is cycle, cross section सामने नजर आ रहा है, इधर हैंडल है, घंटी लगा देने इतने. This is normal reaction. Now here is the normal reaction in this direction. Let it be black. This is normal reaction at an angle theta. Cyclist the weight है mg, m की है, r की है, v की है. These are the standard term. N is resolved as n cos theta, and here towards the center it is n sin theta. Now what is centripetal force here? mv square by r towards the center only force is n sin theta. अच्छा, also एक चीज चेक करो, n cos theta किदे इक्वल है mg दे, सो mg की आ जाएगा mg इज n cos theta, डिवाइड कर दियो 1 डिवाइडेड बाय 2, एक ही आ गया सर, ये आ गया mv स्क्वायर बाय r, दिस इज mg, इधर किया गया सर, ए बचा टेंजेंट थीटा, m कैंसल, v इज अंडर रूट आर जी टेंजेंट थीटा। सर ये तो वही है जेडी हुनी बैंकिंग ऑफ सर्कुलर ट्रैक च आंसर है, यस बैंकिंग ऑफ सर्कुलर ट्रैक भी अंडर रूट आर जी टेंजेंट थीटा, बेंडिंग ऑफ साइक्लिस्ट भी अंडर रूट आर जी टेंजेंट थीटा। वाई साइक्लिस्ट बेंड, क्यों बेंड करता है बेटा?
सर मोशन ज्यादा हो गया।
नहीं बेटा, बेंड्स सो दैट component of normal reaction gives centripetal force. Good to go?
यस सर।
हाँ ठीक है डियर। सो अज का आर्टिकल है, कल मिलते हैं अगे क्वेश्चन करते हैं, ठीक है? अज नहीं है बेटा।